Suppose we have two vectors, A and B. Vectors A and B lie in some plane that I'll signify by shading this in. We're about to show that the cross product between vectors A and B is a vector that is perpendicular to both vectors A and vector B. We will call this vector that's perpendicular to A and B C vector. And we will show that C vector is perpendicular to both vectors A and vector B. So to show this, let's recall something about the dot product. Remember, the dot product between two vectors, and I'll call two vectors R and S. Let's say we have two vectors R and S. The dot product between those two vectors is equal to the product of the magnitudes of each vector times the cosine of the angle between them. If we want to show that two vectors are orthogonal, we just have to show that the cosine of the angle between those two vectors is equal to 0. Now, the cosine of the angle between two vectors from the dot product is given as the dot product between those two vectors divided by the product of the magnitudes of those two vectors. If those two vectors are orthogonal, we have to show that this result is equal to 0, or quite simply that the dot product between the two is equal to 0 once we multiply through by the product of the magnitudes. So we're going to use this property of the dot product to help us show that the cross product of two vectors is orthogonal to each of the vectors that it's comprised of. So we'll start. We'll just first start with show that A cross B is orthogonal, perpendicular to vector A. So let's start off with A cross B. And let's use the fact that we know that two vectors are orthogonal if their dot product is equal to 0. So let's set that A cross B being one of our vectors. If we dot it with vector A, we have to show that that is equal to 0. To evaluate this, let's write out what the cross product is between vectors A and B. The cross product between vectors A and B is a vector with 3 components. The x component of that vector is based off of the product of the y component of vector A and the z component of vector B minus the z component of vector A and the y component of vector B. The y component is given by the z component of vector A and the x component of vector B minus the x component of vector A and the z component of vector B. And the z component is given as the x component of vector A times the y component of vector B minus the y component of vector A times the x component of vector B. So then, vector A cross vector B, dot it with vector A, is going to be equivalent to, and I'm going to just copy the work we've already done. That's going to be equivalent to the cross product between those two vectors dotted with vector A. When we evaluate this, and let me write this out, A cross B dotted with vector A is equal to, okay, we are dotting this. So remember, when we take the dot product, it is the sum of the products of the components. So it'll be the x component. So A1 times the quantity A2B3 minus A3B2. Then we have the y component. When we evaluate the y component, that will be A2 times the quantity A3B1 minus A1B3, and then the z component. The z component, and I'll write it right here, will be A3 times the quantity A1B2 minus A2B1. Let's write this all out. So that is A1, A2, B3. I am just distributing between the terms, minus A1, A3, B2, plus A2, A3, B1 minus A2, A1, B3 plus A3, A1, B2 minus A3, A2, B1. So the dot product of the cross product of A and B with vector A is equal to, well, let's simplify. It looks like some terms are going to cancel. So I see A1, A2, B3 is the third term. And look, the last term in this line is A2, A1, B3. Those two terms cancel. Now I'm looking at minus A1, A3, B2. That cancels with A3, A1, B2. And now I see A2, A3, B1 cancels with A3, A2, B1. Notice that ends up being equal to 0. And since A cross B is itself a vector, that means the cross product of A and B dotted with a vector is equal to 0. And remember, when the dot product between two vectors is equal to 0, those vectors are orthogonal. Therefore, the vector A cross B is perpendicular to vector A. We could do the exact same work that we just did here to show that A cross B is also perpendicular to vector B. With this said, we know that the two vectors are perpendicular, that the vector formed from the cross product of A and B is perpendicular to both the vectors that comprise it.